30% of every material delivered to a construction site wasted. Timber that could have been a welfare bench, concrete that could have been a site road, rebar that could have been chair bars for the next pour. Just gone. In the next 12 minutes, I'm going to show you a complete on-site segregation and reuse system. 8 waste streams, color-coded from day one, and specifically what your team can build, lay, and reuse from materials that most sites throw away without thinking. And I'll show you how to turn all of that into diversion evidence that holds up in any audit. Stay with me. The skip on your site right now contains things you still need.
Every construction project generates the same 8 waste streams. The ratio changes. The streams do not. Concrete and masonry. On most commercial projects, this is your highest volume stream. That rubble pile in the photo is not waste. It is a sub-base material waiting to be crushed. Timber and formwork. Second highest by volume and the highest reuse potential of anything on site. A single formwork panel can run 4 to 6 cycles before it becomes actual waste. Soil and excavation spoil. The largest stream by total weight on any earthworks project, and one of the most consistently undervalued reuse opportunities in construction. Metals, steel and rebar. Lowest volume on the project, highest commercial value per ton, and most sites throw it away. 4 more streams, each one managed differently. Gypsum and plasterboard. This one catches a lot of sites out. It must be kept completely separate from concrete waste. If they end up in the same skip, they create toxic hydrogen sulfide gas in landfill. That is not a compliance issue. That is a safety issue. Packaging and plastics, significant volume. Fully recyclable if you keep it clean and dry. Most sites don't bother. That's a missed opportunity. Hazardous waste. Lowest volume, highest risk. Licensed contractor, every collection. No exceptions, ever. And residual mixed waste. Everything that remains after proper segregation. Your benchmark target is under 5% of total waste generation. If your residual skip is your fullest one, your system has failed.
Let's put some numbers on this. Between 10 and 15% of all materials delivered to a construction site become waste on that site. 70% or more of it can be diverted from landfill when a proper segregation system is in place. And here is the one that surprises most site managers. 30% of all construction waste comes from excess ordering and procurement error. Not from poor site practice, not from bad operatives, from the procurement meeting. 7 streams, 7 colors, 1 container per stream, no exceptions. Yellow, general non-hazardous. Blue, inert concrete and masonry, your primary reuse stream. This one does not go to disposal before we've considered crushing it on site. Red, hazardous, licensed contractor every time. Green, timber and organic, reuse first. Gray, metal scrap, high value. Keep it clean and separate. It is not a disposal cost, it is a revenue line. Brown, soil and excavated material. Topsoil and subsoil in separate containers. Black, residual mixed waste. Last resort only. Target, under 5%. And one rule that most sites miss completely. Your reuse zone is not part of your waste zone. Clean, reusable materials go to a separate holding area, not a skip. We cover this in the next slide. Step 1. Identify your waste streams before any skip arrives on site. Map every material entering the project to its end-of-life stream. Do this at mobilization, not after the first skip is full. Step 2. Hard standing only. Concrete pad or sealed compacted base. Covered. Clear vehicle access. Away from drainage. Non-negotiable. Step 3. One container per stream. Color-coded, labeled, dated. No mixing. Not even streams that seem similar. Step 4. This is the one most sites get wrong. Position your reuse zone separately from your waste zone. Physically separate, clearly signed, managed. A clean timber offcut going to a reuse rack is a completely different category from timber going to a skip. Treat them differently from day one. Step 5. Brief operatives every day. 2 minutes. Walk every trade to the zones. Step 6. Log it weekly. Weight, volume, photograph. This data is your diversion evidence.
Concrete and masonry, highest volume stream on most construction sites, and the most reusable. Option 1. Bring a mobile crusher on site. A track-mounted jaw crusher takes concrete rubble and produces recycled concrete aggregate, suitable for subbase, access roads, hard-standing pads, trench backfill. You are eliminating a disposal load and replacing an import of virgin aggregate in a single operation. Option 2. Broken blocks and masonry units. Reuse directly at site drainage sump covers, slope protection, embankment channel lining. Stack them, use them, don't skip them. Option 3. Concrete chunks for erosion control. Line drainage channels, stabilize embankment faces. Materials you already have. And option 4, your concrete washout pit. Settle the slurry, recover the aggregate for backfill, reclaim the water for dust suppression. Nothing wasted.
That is crushed concrete rubble from this site, now compacted as the site access road. Zero import of virgin aggregate. 12 to 18 tons diverted per 100 meters of road. Every crushed ton is a ton not imported, and a ton not sent to landfill. Timber offcuts. Most sites throw these in a general skip on the same day they're cut. Let's talk about what they could be instead. Item 1. A site notice board or welfare board. Plywood sheet, timber frame, a few screws. That is your mandatory welfare display board, your toolbox talk records, your permit boards, all in one structure. A purchased equivalent costs anywhere from 800 to 2,000 Saudi riyals. Your offcuts? Built it for nothing. Item 2. Directional and hazard signboards. Offcut timber frames, plywood, paint. No entry. PPE required. Zone markers. Every sign your site needs? Zero procurement cost. Item 3. Hoarding and temporary screening. Full plywood sheets and stud work, site boundary hoarding, dust screens, noise barriers. Item 4. Site furniture. Scaffold boards and timber offcuts, welfare canteen benches, boot room seating, outdoor tables. One carpenter, half a day. Zero material cost. And there is more. Tool and equipment storage racks. Wall-mounted timber frames in your site container or office. Organize hand tools, PPE, small equipment. Reduces loss, reduces damage, reduces replacement cost. Material protection casing. Timber offcuts wrapped around exposed pipes, cable conduits, rebar projections. Prevents damage during construction, prevents injury. Costs nothing. Temporary kickers and edge protection. Short offcuts form concrete kickers at slab edges. Temporary curbing for vehicle tracking areas. Drainage channel lining. Plywood sheets lining open drainage channels during earthworks. Prevents erosion and silt runoff into the drainage network. One skilled carpenter. Half a day, timber offcuts. A site notice board, a tool rack, and a bench. Zero procurement. Zero skip cost. Denailing a formwork panel. Stacking it for the next pour. Every item in that welfare area was made from timber that would have gone into a skip. None of it was purchased. None of it cost the project anything. And every reused panel is waste diverted from landfill. Steel and metal scrap, your highest value waste stream by unit weight, and most site teams treat it as a disposal problem. Rebar offcuts. Anything over 300 millimeters is a chair bar, a spacer, or a tie wire former for the next pour. Never buy those if you have offcuts on site. Rebar wired into grills, covers for open drainage sumps, cable trenches, inspection pits. No cost, no procurement. Short rebar stakes anchor temporary fencing, safety netting, erosion control matting to the ground, driven in by hand. And after all on-site reuse, sell the scrap. Bundle by diameter, record the weight, retain the receipt. This is income, not a disposal cost. On a large structural project, scrap metal revenue can offset 15 to 20% of your total waste management costs. Soil and excavated material. The largest stream by total weight on any earthworks project, and one of the most consistently undervalued reuse opportunities in construction. Rule 1, and this is absolute. Always segregate topsoil from subsoil during stripping. 2 separate stockpile areas from the first day of earthworks. Never mix them. Topsoil, mound to a maximum of 2 meters. Seed with temporary grass. Protect the biological structure. This material is reinstated at practical completion. It is a project asset, not a waste product. Subsoil, assess for reuse as engineered fill. If it passes geotechnical review, you have eliminated an import of fill material and a disposal load in one decision. Surplus aggregate, stockpile, cover, label. Offer to nearby groundwork projects before arranging disposal. Eliminates a collection and replaces a virgin material import at the same time. You can run the best reuse system on the site and still fail your documentation if you cannot prove it. 5 fields per load every time. Date of removal, waste stream and material type, weight in kilograms or tons, disposal or reuse route, recycler certificate reference. The diversion rate formula, weight diverted, that is recycled plus reused plus salvaged, divided by total waste generated, multiplied by 100. The sample log on screen, 17.4 tons diverted out of 18.9 total, 92% diversion rate. Documented, verifiable, submitted. Without the weekly log, without the photographs, without the receipts, none of that is verifiable. The data is the system. 2 waste zones. 1 is passing. 1 is being failed. On the left, hard-standing pad, covered containers, each one labeled and color-coded. Reuse zones separate and signed. Weekly photo log with timestamps on file. A waste manifest retained for every load that left site. On the right, waste on bare soil beside a site drain. 1 skip with concrete, timber, and plastic all in it. No records at all. We just clear it when it's full. Everything piled together, nothing identified for reuse. And for the manifests, the driver takes it. That is not a waste management system. That is hoping for the best. The difference between these 2 zones is not budget. It is a decision at mobilization. Before any bin is placed on site, the most powerful waste management action is generating less waste in the first place. Strategy 1. Precision cutting plans. Issue material cutting optimization sheets to every trade before each work package begins. A 5% improvement in cut efficiency on a large structural project can eliminate tons of waste before it's even generated. That's a 1-page document handed to a foreman. Strategy 2. Just-in-time material ordering. Excess ordering drives 25 to 30% of all construction waste. Phase your deliveries. Coordinate with procurement. Materials not on site cannot become waste. Strategy 3. Material take-back agreements. Negotiate return clauses with suppliers before placing any order. Unused blocks, tiles, insulation, cable returned for credit. This is a procurement decision made before mobilization that eliminates waste at source. 6 actions, starting Monday. 1. Map your waste streams before any skip arrives. List every material on site. Identify its reuse potential first, disposal route second. 2. Identify 3 reuse outputs your site can produce this month. Concrete to the crusher, timber to a noticeboard or bench, rebar offcuts to chair bars. 3. Set up a reuse zone, separate from the waste zone, clearly signed, a named reuse coordinator responsible for it. 4. Issue cutting plans to all trades before each work package. The week before, coordinate with your foreman. 5. Start your waste log on day 1, not day 15, day 1. 5 columns, updated every week. 6. Set your diversion target and review it monthly. 50% minimum, 75 if lead credits are in scope. Download the waste segregation and reuse tracking template, link in the description. And if this video gave you something useful, subscribe to EnviroVerge and share it with your site team. This system works better when everyone on the project understands it.